Okay, so let's talk about within groups design and mixed designs today. So these are all the terms that you have to know. So of course that we're talking about within subjects design today. And now with a lot of them, it comes with its own set of problems. But overall, you'll see that within subjects design, or you might want to call it the within groups design, this is still a very good way to do do experiments. Okay, so because this is the same person that is being exposed to multiple conditions, so what happens is that you don't have subject variables as one of the source of errors. Now instead, time or uh, things that are associated with the problem with the time, and especially with the repeated exposures to different conditions, that becomes the source of your errors. Okay. And then we'll also talk about mixed designs, which means that you have two variables at the very least, and one of the variable is within subjects and another variable is between subjects. Okay, so we'll go over both of these. All right, now within subjects design, another term that you've heard it as the repeated measure design. So this is when each subject in the study undergoes more than one level of the independent variable. Okay, so let's talk about, let's say if you're interested in effect of coffee consumed on attention, then then you have exactly the same subjects drink like zero coffee, and then you would test them on attention, and then you give them 1 cup of coffee, and then you test them on the attention again, and then you give them another cup of coffee, which make it 2 cups of coffee, and then you test their attention again. So it's the same subjects that goes through these different levels of the independent variable. All of them go through all of the independent variables. Okay. Now this is very popular because are several reasons, and one is that within subject design is very sensitive, meaning that you don't have that many people, you don't need that many people in order to find a difference, and also it has very high power when you do statistical tests. Okay, and then so basically what within subjects design is that when subjects serve as their own control, and therefore there is no such thing as between subjects variabilities in the within subjects design. Now these are the reasons to choose repeated measure design, and as I said that it has very high sensitivity. Okay, and the reason is that it has very low amount of error variation that you usually see between conditions. Now, when you kind of think about across conditions in the between subjects design, one subject is assigned to one condition and another subject is assigned to another condition, right? And then the problem is that you don't know if the differences that you're seeing between the conditions, is this really due to the manipulation or is this due to the subject variability, right? And then you don't have this problem in repeated measure design or within groups design. And so that's the first reason. And then the second reason is that it's, well, you have a better use of subjects, right? So let's say if you have 3 conditions and if you are using n of 3 for each condition, then what happens is that you need, for the between subjects design, you need to have 9 people, right, to get an n of 3 for each condition. But if you use, but let's say if you're using a repeated measure design, you only need an n of 3 for the entire study. Okay, so it's always a good idea whenever you can, you should use a repeated measure design. Okay, and now the third reason, sometimes it just you have to use a repeated measure design, And that is because, let's say if you're using age as a variable, and then so this will make it a longitudinal design in which you are tracking the same person over a long period of time. Okay, so let's say if you are interested in development of children, and then you're tracking the same um, group of babies, you track them when they were 0 years old, and then when they were 1 year old, when they were 2 years old, and so forth. So this would be a longitudinal design, and then you're just looking at the age of the babies as a variable. Okay. Now, another scenario is when you have the study about carryover effects. So let's say you are wondering how long does coffee stay in your system after you drink them, and well, therefore, what you need to test the same person over and over and over and over again, because this is the best way to have a baseline about a person, and then you can exactly track what is basically how the coffee is lingering in the system, right? Now, there are some problems that you see only that are associated with repeated measure design. So one is irreversible manipulations. And you see this a lot in learning and memory paradigms. So basically, once you have learned something, you cannot go back to unlearn something. So this kind of like similar things is like once you found out that your boyfriend or girlfriend has been cheating on you, and then the way you feel about him or her is just forever changed. You're just like, I just really wish I never found out. So there are things that you just can never go back to the way it used to be. So, and so this is definitely a problem with repeat and measure design, because what happened is that you cannot unlearn something once you learn it. Now, of course, if you are interested in learning and memory, this is a great tool, because you can say that, okay, so for instance, you are interested in knowing how how good does it get for a person to improve on their accuracy when they are throwing darts, right? And once they get very good at throwing darts, they cannot go back and just purposefully make them bad again, right? So this is the thing about learning paradigms. Now, if you're interested in just how long does it take to become really good in throwing darts, and that's just basically motor learning, right? So that's something that you can really get a good idea at, and in this case, the only proper way to study it would be a repeat and measure design, because you have to track the progress of a person's ability and their improvement on their dart throwing accuracy in order to kind of get an idea how much percentage is improved from the last time they did it, and so forth. Okay, so the second question that's a problem that is only associated with repeat and measure design is order effects. Now, order effect is the order of things that was exposed. All right, so we'll talk about it later. And then the third one is sequence effect. And like order effect and sequence effect, they sound very similar. Well, they are kind of related, but they're not exactly the same. And in the subsequent slide, you'll see what I mean. Okay, so what is the difference and the similarities of the water effect and the sequence effect? Well, the water effect is the water in which the participant received had kind of effect on the outcome of conditions. So this is on one condition only. Okay, as opposed to the sequence effect is participant who received one sequence of treatment scored differently than participants who received another sequence of treatment. And this is more like on an overall thing. So let's say you can kind of think of water effect as uh, the fact that you were exposed to condition A first had the subsequent effect on your performance on condition B. Okay, So let's say if I went through one condition and then, and I had and then the manipulation of that condition made me in a very bad mood. And then when I have to go through the next condition, well, my mood is already affected. So then in the one, so in the one that I went through a very bad mood, then my performance is going to be really affected. Okay, as opposed to sequence effect is that the participants went through all of these different treatments and their eventual outcome is different than the participant who received another sequence of treatment. Okay, so the order effect, you can kind of think of it as, let's say if you have a chemistry test and you have a psychology test at the same day. And then, so over here on the top here, you have the test order that you are doing is you did test A first, followed by test B. So let's say test A is chemistry. So you did chemistry exam first, and then you had the psychology exam. Okay, and the other one is when you have, let's say, the psychology exam first, and then the other one is when you have the chemistry exam second. Okay, so you can see that, how these can both different orders can actually really have a difference on your eventual like sum score. And you can kind of think of it as, oh, I didn't do so well on the psychology exam here, and it's because over here I used up all my brain powers, I didn't have any more left to do well on the psychology exam, right? Now, as opposed to if you had the test order a BA in which you had the psychology exam first and you're like, oh, that was pretty easy. I think I did pretty well. And then you go on to the exam, your chemistry exam, you're like, oh, I really aced that psychology exam. And no matter what happens, I know even if I don't do that well here, I am gonna be okay. And so you went into this exam the chemistry exam more relaxed, and then and I'm not saying that psychology is so much easier than chemistry, but then chances are because you are a psychology student, you like psychology more, so therefore it's easier for you. And then and this is why when you go into the chemistry exam and you're like, oh my God, I know I studied for it, but then that was so hard. But I'm really glad I took that psychology exam first because I didn't have to worry about it, and then therefore you did okay on in this case on the chemistry exam, right? And you can kind of think about what does this how does this actually influence your, let's say, GPA at the end? So the test order that in which you had chemistry followed by psychology, you may do okay on the chemistry exam, but you did horrible on psychology exam. You're just like, oh, I'm just like so tired following that chemistry, that grueling, brutal exam, and therefore, your GPA is kind of not that good, as opposed to the second scenario, you did the psychology exam first, followed by the chemistry exam. At the very end, you're very, very tired, but then your GPA is, well, a little bit better. Okay. So basically, that would be a classic example of the water effect. Now, there are several sources of the water effect. So one of them can be something like a practice effect, right? And then, so this is the fact that learning and getting used to the paradigm has affected the performance on the participants. So this is something that you guys are pretty much discovering that is the case in your lab number 2, right? So this can be averaged out by the subjects going through like all the practice effects. So that's a good way of limiting the practice effect, in which that you're saying that, okay, I will not count your first trial of this experiment, but rather I am only going to count the second or the third trial of all the experiments. Okay, because there are always first time jitters when you are encountering something new. Okay, so that's the first source. Second source is carryover effect of the order effect, and this just basically the delay with the lingering effect of the previous treatment. Okay, and then the third effect is the fatigue effect. So basically, let's imagine that you're doing something over and over and over and over again, and eventually the subject becomes tired and you're like, I'm exhausted, I don't want to do this anymore, and then what happens is that they start to make errors, right? And then what they start to become less enthusiastic. They are less motivated, and then what happens is that the cognitive performances or whatever performances that you are trying to assess psychologically is does not really reflect their natural state, but rather it reflects their pooped out state. Okay. Right. Now the fourth source of order effect is sensitization. So this is after repeated exposures, they start to catch on what the hypothesis is about. This is kind of similar to demand characteristics. So this can also not only affect a lot of the internal validity, but also the construct validity as well. As opposed to like the first three that we're talking about, this really only affects the internal validity. Now, the sequence effect is slightly different from the order effect. The sequence effect is the interactions among all the conditions themselves. Okay, so the example of that is, let's say you are intended, you're kind of interested in seeing which sequence of ritual can help you the most to get the best grade on the midterm. There are the four things that you usually do before an exam. So you usually run, meditate, drink coffee, and then study, right? And and so in one scenario, let's say you meditated first, and then you study second, and then the third thing you did is exercise, and the fourth thing you drink coffee. Okay, and then the grade that you receive is this. Okay, now let's say in another scenario, if you were to do exactly the four rituals but in a different sequence, and if you took exactly the same exam, so let's say if you exercise first and you meditate second and you drink a coffee third and then you study last, and then the exam that you got was actually a lot better. So this is basically kind of tells you that the well, I know the order is different, but then the more important thing is that the sequence is different. Okay, so which means is that how the first event affected the second event, affected the third event, and then affected the fourth event, and how all of these eventually contributed to your performance. Okay, it's not really all about um, like the order of things. Okay, so but it's more like the sequence of things. So in other words, order effect and sequence effect they are very similar, but order is only how one condition caused the next condition to be different. But the sequence effect is the conglomeration of all of that, and how does that affect your actual mental performance or the outcome that you're looking for. Now, what are some of the strategies that you can use to balance out the order effects? So that would be the counterbalancing techniques. So these are the techniques that's used to control order effects by systematically distributing order effects across treatment conditions. Okay, now there are many counterbalancing techniques. So there is the AB/BA counterbalancing. So that's the example that you saw in above. So one half of the participants got the sequence A followed by B, and then the other half got the sequence B followed by A. Okay, so that would be the ABBA counterbalancing. And there is all possible orders, and then the third technique is called the Latin square. So now the ABBA counterbalancing is basically something that we've said in the previous slide. So you have half of the people gets the test order A followed by B, and then the other half gets the test order B followed by A. And so now when you kind of balance them out, then you have a better idea of saying that is test A really harder or easier than test B. Now with the all possible orders, basically you're looking at let's say when you have two levels of independent variable, then it's the same as the ABBA counterbalancing. And when you have three levels of the independent variable, then you get the order like ABC, ACB, BAC, BCA, CAB, CBA, right? So this is all the possible orders that are within uh, the entire study, okay? And we have four levels of the independent variable, then you get ABCD, ABDC, ACBD, ACDB, you know, and so forth. All right, now, so basically you are gonna get this conditions, okay? So so for three levels, you will have 3 times 2 times 1, which is equals 6 conditions that you see here, right? And then for four levels, then you get 4 times 3 times 2 times 1, which is going to equal to 24 conditions. And so for 5 levels, you get 120. And then for 6 levels, you get 720 conditions. All right, now you are probably thinking that, well, that doesn't really make sense because let's imagine if I have 5 levels of if I have 5 levels of my independent variables, then I need to have 120 conditions in order to satisfy and counterbalance out all of that order effect, right? But professor, you just told me that one of the main advantages of having a repeated measure design is that I can cut down on my subjects. And now you're telling me I need to have 120 subjects? I mean, what the hell? I mean, this is so conflicted. Well, you are right. So mostly people they would only do all possible orders up to 3 levels, and in some cases, if it's a very large scale studies, maybe 4 levels, okay? But 5 levels or 6 levels is unheard of. Okay, so you're thinking that, well, then is there like an easier way when you kind of you know still address this problem? Well, there is, and that is called the Latin square. Okay, so in the Latin square, the general rule for balancing the order effect is met. But there's something I want to say is that the Latin square does not address the sequencing effect. The all possible order does. Okay, so the main differences with Latin square and all possible order is that all possible order addresses the sequencing effect, the sequence effect, and then the Latin square only address the order effect. Now, the all possible order does not only address the sequence effect, it also addresses the order effect. So all possible orders is going to address both sequencing effect and the order effect, but the Latin square only addresses the order effect. Okay. Now, for each condition, in Latin square, each condition appears in each ordinal position once. Okay, and the Latin square only controls for order effect, and as I said, it does not control for the sequence effect. Now, how do we construct a Latin square? So this is actually something kind of fun if you like doing this kind of things. So the first thing you need to randomly order the conditions of the experiment. Okay, so and then the second thing you want to do is you want to number the conditions in your random order 1 through n. So let's say so to generate the first row, you need to use this rule: 1 comma 2, comma n. So let's say if there are 5 people in 5 conditions in your group, the n will be 5. Okay, comma 3, comma n minus 1, comma 4 minus n minus 2, comma 5, comma n minus 3, and so forth. Okay. And now to generate the second row, and what you need to do is you add the first row, but with the understanding that 1 added to n equals 1. Okay, and so forth. Okay, and then you just kind of follow this rule until your Latin square is completed. Okay, so let me just kind of demonstrate it for you. So let's say if you have 5 conditions, you got conditions A, B, C, D, E, and you want to construct a Latin square. So the first thing that we will do is we will randomize the order, and we come up with this order C, A, E, D, B. Okay, so from now on, C equals 1, A equals 2, E equals 3, D equals 4, and B equals 5. And then, so as I said, to construct the first row, then you need to have 1, comma 2, comma n, comma 3, comma n minus 1. Okay, which in this case is going to be 1, 2, 5, 3, 4, right? And then so then you just apply these these conditions. Then your first row will be C, A, B, E, D. Right? Okay. And then the second row is then going to become that each number in the first row, and then the n plus 1 will be 1. Okay, so the first row was 1, 2, 5, 3, 4, right? And then what happened is that means your second row will be 2, 3, 1, 4, 5. Okay, and which means that your second row is going to be A, E, C, D, B. Okay, and then you just basically you do exactly the same step in the second row for the rest of the rows, and then you get all of these following. Okay, you can kind of, if you didn't get that, you can kind of go back to the slides until you kind of figure it out, where you can type in and try to Google how to construct a Latin square. Okay, so now what happens is that your finished Latin square is going to look like this. Okay, so group 1 is that, and group 2 is this, and so forth. Now, so this way you only need to have you don't need to have like 120 groups. You only need 5. You only need 5 orders. Okay, now let's see what happens with this. So now let's just take a look at C, for instance. Okay, so I'm gonna use red. Okay, C occurs in the first ordinal once, does not occur in any other ordinals, and it occurs in the third ordinal once. It occurs in the fifth ordinal once, in the fourth ordinal once, and the second ordinal only once. Okay. So that's C, and let's take a look at A. It only happens in the second ordinal once. It happens in the first ordinal once. It happens in the third ordinal once. It happens in the last ordinal once, and it happens only in the fourth ordinal once. So this is kind of similar to Sudoku. Okay, if you kind of like it, so you can see that each condition is only going to appear in the ordinal once. Okay, so this is basically tells you that the general rule of this of where it is within the entire chain of the ordinal is satisfied. Okay. Now let's talk about the pre-test, post-test design. Okay, so this is a one special kind of repeat and measure design. And so each participant will given a test before the treatment and then test them again after the treatment. So you can see that, so when you kind of think about it, this is basically, let's say, you are interested in the effect of consuming caffeine. Okay, so what happens is that you have participants come in and then you test their attention level before they drink any coffee, and then you give them the coffee, you let them drink them, and then maybe let's say you give them like 20 minutes to digest the coffee, and then you test their attention again. Okay, and now is there a way for you to test their attention first after you give them a drink of coffee, and then 20 minutes later then you test them again and you say that well, this 20 minutes after they drink coffee conditions, this is without any caffeine in the system. You cannot say that because the caffeine, well, after 20 minutes it most likely is still in their system. Okay, so you can kind of think about this. Usually, the way that you only have this kind of work is done is only one direction. Your pre-test is always your baseline, and then the post-test is always after the manipulation has been done. Okay, so and this is usually when the treatment is irreversible, when it's long lasting. And then so therefore you don't have to and you cannot do counterbalancing for that fact, for that matter. Okay, so because it's not valid or it's not possible. Okay, so basically that's what this looks like. So you have before manipulation and you have after manipulation. Okay, and then there's the manipulation period, and in here you gave it some sort of manipulation. And then you compare the dependent variable value before and after the treatment. Now, what would you do to improve this kind of design? Because something that we said before, a lot can happen between this and here, right? So now imagine if this is something, if there's a very long time that passes between the before manipulation and after manipulation, there could be a significant amount of, let's say, history that happens, or that could be a lot of significant aspect in terms of, let's say, maturation, or the system that you are testing it at is went through some malfunctioning. So something that we said when we were talking about the internal validity lectures, in which that basically uh, you won't know if the differences you're seeing before the manipulation or after the manipulation is really due to the manipulation, right? So what you can do is, like we said, to have a pre-test, post-test design in which group 1 is the treatment group that receives the treatment, and the group 2 is the placebo control group that received no treatment. Now, in this case, how many independent variables do you have? Well, you will have 2, right? You will have the manipulation period being one of the variables, so before treatment and after treatment, right? And so that's the first one. And the second one is the treatment group versus the placebo control group, right? So now think about this, okay? So this is the same, so group 1 went through before manipulation and after manipulation. So that means that it's the same person before and after. And these are exactly the people who receive treatment. And then in another group, group 2, they do not receive any kind of treatment. So basically you have one of the independent variable that is within group and another independent variable that is between groups. Okay, so this is a mixed design. So whenever you have two independent variables, but one of the independent variable is within group, another one is between groups, then you call this a mixed design. Okay. Okay, so basically you have two independent variables. In independent variable 1 is the time of the assessment with 2 levels, right? And so you have between the manipulation period and you have after the manipulation period. And the second independent variable is a treatment type received with 2 levels. One received the real treatment and then another one received the placebo treatment. Okay, so the first independent variable, which is the time of assessment, this is within group. right? And then the other one, the type of treatment received with the two levels, this is going to be between groups. So this will make it a mixed design. So whenever you hear mixed design, you would know that this particular study involves at least two independent variables. Okay, so basically that's the gist. So when you have mixed design, when one factor is between subject and when the other factor is within subject. Okay, now let's go back and talk about quasi experiment. Okay, so this is when the study lacks a random assignment or that lacks a real manipulation. Now we kind of think about what do you mean a study lacks a random assignment? Well, the reason why it lacks random assignment is that because you cannot assign them based on random because they already belong to a group. So let's say male versus female, you cannot just say, okay, I randomly assign you to the male group. I randomly assign you to the female group. You cannot do that because they are already born male or female. So this was already predetermined on whichever sex that they were born with, right? So this is a characteristic of the subjects that they already possess, right? So therefore, the study lacks random assignment. So now think about it. So that would mean that there would be no manipulation that's being done because you're not manipulating the sex. You're just assigning. You say that okay, you're a male, you go to this group. You're a female, you go to this group. You're not manipulating anything, right? And then so what happens is that the study's independent variable is lacks basically lacks the manipulation. Sometimes they say you are interested in gender, sometimes you're interested in age, and neither of the things you can manipulate. Okay, so whenever you see gender or age, you can know that this is some sort of quasi experiment already. Okay. Now, what is a hybrid design? Well, a hybrid design is when you have two independent variables, and then when one of them is manipulated and the other one is not manipulated. So let's say if you're interested in the effect of drinking coffee on attention in both male and different and male and females, so now you have two independent variables. One is the amount of coffee consumed, and the second one is the sex of the participants. And your dependent variable is attention, a measurement, right? And then so this will make it a hybrid design. And because one of the variables you can manipulate, that's the amount of the caffeine that's consumed. And the other independent variable, which is gender, you are not manipulating, but you are just assigning them based on whatever group that they belong to. So whenever you have a crisscross of one of the independent variable is manipulated, the other one is not manipulated, you have something called the hybrid design. Okay. Now, I just want to mention one of them, and this is when you have age as an independent variable. So, and this is something that you guys hear quite frequently. A lot of time you will hear something like a cross-sectional design or a longitudinal design. Okay, and so I'll tell you one of them is between groups and the other one is within groups. Right? And then both of these, they use age of the participants of the independent variable. Okay, so which means that whenever you hear longitudinal design or if you hear cross-sectional design, this is a quasi experiment. This will make it a quasi experiment because you're not manipulating the age of the participants. Okay, now cross-sectional design is what? Cross-sectional design is when you gather many different ages of people at one time. Let's say in 2020, I am gathering people who are 5 years old, 15 years old, 25 years old, 35 years old, and I'm gathering these groups of people in one sitting, and there are young people, there are older people, and so forth. And I'm interested in the effect of age on whatever, okay, whatever dependent variable that you're interested in. So that would make it a cross-sectional design, which means that it's between groups. Okay, now longitudinal design is when you are tracking the same person over a very long period of time. Now, if you have watched the documentary called 7 Up or 14 Up or 21 Up, so this is basically the documentary in which that they follow the same person, every group of people from birth, and then they would follow these people every 7 years, and then they would document their lives. I think they're up to 50 something years of age already. And so that would make it a very long longitudinal design. Okay, so now since you're tracking the same person over a very long time, this is of course a within groups design. Okay, and so that concludes today's lecture on within group subjects and the mixed designs. Next time, I think we are going to talk a little bit about not so much of an experiment level, but we're going to talk about some other research methods such as single-end subject design. Okay.